Counter. A counter is a sequential circuit. A counter in principle is a register whose value is incremented by 1 on the occurrence of some event. When the value stored in counter reaches the maximum value it can store, the next incremented value becomes 0. There are two types of counters: asynchronous counter, synchronous counter. Asynchronous counters. Asynchronous counters do not have a common clock that controls all the flip-flop stages. The control clock is input to the first stage or the LSB stage of the counter. The clock for each subsequent stage is obtained from the flip-flop from the prior stage. A 2-bit asynchronous counter. The counter has 2 flip-flops and 2 output bits. Therefore, it is a 2-stage counter. The input clock does not trigger both flip-flops, therefore it is an asynchronous counter. The J and K inputs are tied together as kept high, so they are considered to be toggle flip-flops. The flip-flops are positive edge triggered. The waveform analysis reveals that Q0 is the LSB and that its frequency is half the input clock frequency. Furthermore, Q1 is the MSB and that its frequency is 1/4 the input clock frequency. The count sequence is 00, 01, 10, 11, where the LSB is Q0. Thus, it is an MOD4 binary up counter. Assume that Q0 and Q1 are low initially. Synchronous counter design. To successfully design synchronous counters, we may employ the following 6 basic steps. Create the state transition diagram. Create a present state next state table, often referred to as the next state table. Expand the table to form the transition table for each flip-flop in the circuit. The transition table shows the flip-flop inputs required to make the counter go from present state to the desired next state. This is also referred to as the excitation table. Determine the logic functions of the J and K inputs as a function of the present states. Analyze the counter to verify the design. Construct and test the counter. Step 1. Creating state transition diagram. Step 2. Creating present state next state table. Step 3. Expand the present state next state table to form the transition table. A 3-bit synchronous counter. Like asynchronous counters, synchronous counters may be designed to meet a variety of specifications. For example, decade counters that count the binary sequence 0 to 9. In addition, we may implement bidirectional counters, that is, they have the ability to count in ascending 0, 1, 2, 3, 4, 5, 6, 7, 8 and descending 8, 7, 6, 5, 4, 3, 2, 1, 0 order. In general, most bidirectional counters can be reversed at any point in their sequences. Example 0, 1, 2, 3, 4, 3, 2, 1, 0, 1, 2, 3, 4.